Alright. It's Saturday afternoon here, getting ready for another stream on my whimsical cat following camera project thing. Normally this camera would be pointed at the cat, but he's upstairs sleeping somewhere that's a little bit beyond its reach currently. So instead, for now you just have me, but we'll keep an eye out for the cat whenever he decides to join us. So I've got this camera right now that's on a tripod. I can move it around, but one of my little side projects I've been working on is, since I live in this warehousey space with these high ceilings, I wanted to just make a camera that can move around on wires basically and follow my cat. So instead of like metal wires, I'm using paracord because it's flexible and pretty lightweight, and I don't need it to be super rigid because I'm not going to be using this as a CNC machine. So mostly what we're dealing with at this point, I've got this work in progress. Oh, I went to pick up this suction base and it was actually suctioned down to the thing it was sitting on. So I've got this work in progress spool thing where there's a motor and a spool of paracord. Let's see if I can fix that. There's a bit of a bad connection in there and sometimes it gets all flickery. I should probably re-terminate one of those coax cables. So anyway, I printed out this spool design because I wanted to test out various aspects, and I actually already have a long list of things that are wrong with it. But I think more concerning actually is that I think this motor is nowhere near strong enough. So we can do a little experiment for that, but yeah, I think mostly I need to do some small changes to the spool design probably, but look for a better motor. There are a couple of issues. There's a lot of variation between the torque that I have available when the spool is full versus when the spool is empty. But even in the best case, it's not that great. I think, so with the spool wound this much, I just measured the stall torque by attaching this loop to like a luggage scale, and it tops out at 0.5 kilogram, which I think might just barely be enough when I have 4 of these holding up the camera, but I think I probably want more power than that. And so I could solve that by having a different ratio, either by using a different gearbox with this motor or by having the spindle be much narrower and having to deal with it be longer and like winding it back and forth. But then I think with this same motor, it would just end up being too slow. So I think I just need a more powerful motor. So I'm going to look around to see what options I have. I had a couple of good suggestions on the last stream, including, I know one favorite that people use are like car windshield wiper motors. I think I thought that those would be too slow, but maybe I could look into modifying them or finding something that's more special purpose, but still not expensive. Another option people suggested was power drill motors. And actually, I had a bit of inspiration in that direction too from James on the X-Robots YouTube channel. Or X-Robot, I think it's singular. Anyway, he builds a lot of robots, so I assume it's plural. And he 3D prints pretty much everything. So there's also a lot of interesting tips there on designing things that don't have to be super strong in small spaces, so you can deal with having chunky plastic parts that still hold up a lot of weight. But he was having a lot of luck actually using motors from really cheap cordless drills and just using the chuck mechanism to hold whatever he wanted. So I might look into something like that too. But the other problem is, since I'm talking about this, I might as well actually just power this on and show you. This is going to be at 12 volts, so the motor will run a little fast. This is like the fastest speed that I would want the controller to have available, basically. But let's run this in reverse so we can unspool some cord. So you can probably see already that it's very wobbly. That's from the joint between the motor shaft and the driving side of the spool. And I think I just made the mistake of having a lot of joints in this design that are really over-constrained. So, like, I don't know, I'm no mechanical engineer, but I'm trying to pick it up bit by bit as I go along. And one of the things that I'm learning and then occasionally forgetting is to design things with, the right number of ways that they're constrained in place physically. So, it helps to have a system that's overall kind of under-constrained, and then to kind of pin it into place in very well-controlled ways. And I think the problem here was the actual geometry of this, D-shaped motor shaft with a set screw does that constraint pretty well, because then it pins it against the curved kind of D on that motor shaft and the screw, and it kind of pins it right in the middle of that curve. So that's actually pretty well constrained. But I over-constrained it by also having a really tight press fit on that shaft. So I think that was just a mistake. I just should have a wider shaft or a wider hole by just a tiny bit, and that would help. There's a lot of stuff that's just too tight on this design. It was really hard to get the two pieces together. If you saw the last stream yesterday, I was sanding this like crazy, trying to get the pieces to fit. I eventually got them to fit all right, but still not quite as well as I would like. So there you go. You can see it's got a through hole there, which is also a little on the small side. Yeah. And then there's a little hole right there, which you can barely see as it goes by, where there's a set screw for the motor shaft. So anyway, since we're actually going to get more of a best case torque, let's see what the best case is. So just have like a basic luggage scale here. And I'm going to, I think I'm just going to temporarily kind of knot this. I could tie a good temporary knot. And so, something like that. And then hook this end up to the scale and run this a little bit to take up some slack. This is going to be a somewhat weird camera angle, but I really want this to be anchored on the table so I'm not like holding it and inadvertently pulling it. I don't know how much I care about all of this being in frame right now, since this is just a really early test, but basically this is what I'm going for, kind of. Whoa. Well, the angle kind of changed, and then it got a little bit screwed up, but it peaked at around 1.1 kilograms or so, which is obviously a very rough measurement, but that tells me something at least. So actually, that would be totally usable. So if I were measuring this a little carefully, I could actually calculate the torque of the motor in foot-pounds or whatever unit you want to use. Well, actually, so maybe that's usable. So I'm just trying to determine whether I can get a combination of torque and speed with this motor that will actually work. But I think actually with this inner diameter, that might be about what I'm looking for. So let's try that test again, just to just because maybe I can get a slightly better version of this. I don't think I can actually lock this down to this desk because it's not really smooth. Oh, it kind of works. I'm gonna have to hold this though. I can sometimes tie knots. something about that glare. Maybe if I just hold this at an angle. I don't like holding this, but I don't really have the right clamps to do this, and I'm feeling lazy about it, so here goes nothing. Just try not to start that with tension on the cord. Oh, just don't turn off. Okay. Whoops. Oh, now it looks like I'm getting up to 0.8 kilograms with that particular angle. You know, that would be enough for the really lightweight kind of robot that I'm thinking of, but it's still on the low side, so I think that's enough fussing with this for now, but I'm going to be looking around for better motors that are in my budget for this project. Because yeah, these motors are really puny, and there's no reason for them to be this small. I mean, everything else in this project can handle something more, you know, something stronger than this. Like the plastic is stronger, the cord is stronger, the load cells can handle more weight, so there's no reason for the motors to be the weak link in this. I mean, there is, but not by this much. Like, this is a very dramatic difference. Like, the motors are much weaker than everything else here is. So I'm going to be looking for some new motors. Just for illustration, maybe I'll take this apart. So M3 screw in here. And then that's a little tight, but not as tight as I thought it was, I guess. And there's an M3 nut kind of forever buried in there now. I put it in with the help of a soldering iron to make it a little easier. And then this cord I can just unknot. The bearing, I might have to destroy the plastic to get out. The bearing is in there pretty tightly. And I don't have the other piece designed for this, but basically, you know, because I want this to be relatively easy to assemble, so the idea is the outer enclosure will come in two halves. There's one half that the motor is actually going to be bolted to, and so that'll have this attached with the set screw, and most of the other hardware will be attached to that half. And then, like, the cover that you put on afterwards will have an M6 bolt and a nut embedded in a really sturdy little standoff that fits into this conical hole there. And so that standoff will fit in here and then actually hold the weight of the cord. So, yeah. Emmy suggests I need a bearing press. Yeah, probably. This one was hard to get in. Yeah, Kenneth and Ben in chat are both suggesting brushless motors. And yeah, it would be nice. I mean, brushless motors are a great way to get a lot of power, and yeah, it makes the gearing harder. I would have to think about the gearing, but that's not necessarily bad. I probably would need to buy gears, since I don't think 3D printed gears would do it, although, I don't know, maybe they would, but, because like brushless motors like running pretty fast, so I would need a lot of reduction, and so unless the gear train is really well made, that sounds loud. But yeah, one option is the brushless motors that are made for like RC cars that already have gear trains. So look into those. I'd been avoiding those before because, I mean, mostly because it seemed like I wanted a worm gear drive so that this would have the kind of braking ability to built in. But there, you know, like folks were pointing out on the last stream, there are other ways of getting the braking. Especially since I'm going to have some other stuff that the cord goes through. It's not going to just come straight off of here, because I want to, you know, I want to have some feedback. I want to sense both the speed that the cord's moving at and the load on the cord. And for both of those, I don't necessarily want to do it directly off of this wheel. Partly because, I don't want to measure the speed that this wheel is rotating so much as I want to measure the speed of the cord, and as the diameter changes, the ratio between those two changes. So I'm planning on having another, well, two more pulleys, basically. One pulley kind of over here that would basically just exist to keep the angle that the cord enters the next pulley constant, even as the spool fills and unfills. And then the next pulley, it would have a constant angle of this cord coming in. It would be going off to a ceiling pulley at a pretty much constant angle, and then that would actually have the load cell in it that measures the force, and it would have an encoder that measures the actual travel of the cord. And that much sensing might be overkill, but I think I could use that to make the control loop nice and smooth for the camera robot. So my goal has been to make the winch robots have that, so that basically I can like tell each individual axis, like, okay, I want you to try to maintain like this force and try to be moving at this speed, and here's your like PID loop parameters. And then all of that will be maintained locally while the Raspberry Pi on the robot does the axis, or does the like multi-axis coordination. That's kind of my plan. Oh yeah, that's a good question too. Ben asks, am I going to wind the cord or excess wear on the wheel, or have a weight that moves, since having a moving weight, like a counterweight, would make the torque requirements a lot less? I've been assuming I'm winding the excess around here because the robot is going to be really light. And that also means that I don't necessarily have to have these all like near the ceiling, which makes maintenance a bit easier. So my assumption here is that what I want to do is have a pulley that's like really high on the ceiling, and that's like, I need to get like a ladder. Well, I have a ladder here, but I need to get like a couple of spotters or friends that like heights a lot more than I do, and attaching a pulley to the ceiling is kind of a big deal here. And then if these were also near the ceiling, then anytime they break, I have to go up there also. So having these be closer to the ground would be really nice. Also, Robert in chat has a link to a procedure for CNC milling and resin casting gears, which I've not tried that, but I'll have to take a look at that. That sounds interesting. And yeah, like I bet I could, like if I do need to make a gear train, like that sounds like it might work. Making a worm gear, I mean, unless I'm using like a screw or like a piece of like all thread or something as a worm gear, but I think I'm probably better off finding a ready-made worm gear box than trying to make that part myself, since I think whatever I make is going to end up being really inferior to something that I can get cheap on eBay already made. But anyway, yeah, lots to think about here. I like the bearing mount. I really made a mess of this with the super glue, because I tried like putting some glue in the joint, then pressing it like this, but then I didn't notice that it was gluing itself to the floor, and then it like pulled up bits to the floor, and so it was not good. I always end up making a mess with super glue, but it seemed like the right adhesive to get these to stick together. And anyway, it seems like a decent prototype for this at least. And this is a really common motor shaft, so I can probably use this to test other motors if I need to. This is a 6mm diameter. I don't know if the D shape is super common, but it's probably pretty close to something that I can get to fit in other motors. Yeah, Ben in chat was just suggesting using some short lengths of lead screw for the worm gear. Yeah, I mean, there's some things I could do to makeshift, but I mean, before I do that, I'm probably just going to actually try shopping for real gearboxes, since, I mean, I think if I have to go the route of having a separate gearbox that's not integrated with the motor, then before I build my own gearbox, I might just try shopping for, can I get just like a cheap gearbox that I can attach to the motor that I want, since I suspect I'll be able to find something like that. I might also just, give the windshield wiper motors another chance, since maybe they aren't too slow. But yeah, I'll have to go shopping for some motors, but I think right now I want to get on to working on the camera mount, since that's maybe more fun, and we can think about this in the background. So, camera mount. Let's go briefly to the computer. that is the computer. That's the only computer we need right at this moment. So the printer is done. Hello, mouse. Did you forget how to mouse, little mouse? That's better. I don't know if this is a grit in the sensor problem, a Wi-Fi problem, or not Wi-Fi, like a wireless problem, or a battery problem. Okay, so let's look at this first in Fusion. So if you saw the last stream yesterday, we've been going through various approaches for how to mount this camera and gimbal that I have to each other. So basically the pieces that we have to work with, this little kind of C-shaped thing, that represents the, excuse me, I think I've got the hiccups now. Or maybe I just drank too much water. So this C-shaped thing, it represents the edge of this existing bracket that the gimbal already had for attaching this other piece of metal that it came with, which mounted to a GoPro. And so kind of disregarding its original GoPro-shaped piece of metal, this is the interface we're dealing with. There's this tunnel that the wiring has to go through, so I need some amount of that to stay open. And it takes these little M2 bolts to... oh, that's interesting. Getting distracted by chat again. Nicholas mentions they have the same motor and they run 20 volts on it, and it seems to handle it okay. That might be worth trying. Yeah, I got a bunch of these motors because I figured that, you know, well, I say a bunch, I think I got like 6 of them or something, because I figured like, oh, I need like 4 of them for this project, but I could also just like start building robots out of them and have them wander around the shop, because they seem like a super useful random little rolly thing motor. But yeah, maybe not the strongest thing for WinchBot objects. And then Ben in chat mentions that I can get NEMA steppers with integrated planetary gearboxes. I have one of those actually. It's in my old 3D printer, my old MakerBot. I put a third-party extruder on it to replace the original DC motor extruder, and it uses a stepper with a planetary gearbox. It's really nice. I don't think that would be fast enough for this, or rather, I mean, I don't know. I wouldn't expect a stepper to be my first choice for this, but maybe I could look into that. But maybe that style of gearbox with a brushless motor would be more my speed. A stepper really probably wouldn't do me much good because I don't really care what speed the spool is moving at, so I think I just want a motor that's pretty efficient. So if I go to a different motor technology, it's probably going to be like not the brushless motors that are optimized for quadcopters, but basically the brushless motors that are optimized for RC cars, the ones with the you know, the kind of the smaller core and usually easier to mount to gearboxes. So this is the aluminum bracket we're mounting onto. It has M2 hardware. Then this is the big old cast aluminum housing for the camera that we're using. And I decided to drill some holes in it here-ish, and there were various constraints going on. Originally I had these placed elsewhere, but basically, you know, if I'm trying to avoid some standoffs right here that I'd like to have screwdriver access to. I want to keep this screw hole and this screw hole clear of each other. I want to have access for the wiring. So with all of those constraints in mind, this was the piece that I ended up with. And so this was mostly designed on the last stream, but I iterated on it a little bit. So there's a channel for the wire, there's screws, more screws, and the channel gets wider at this side because I need room for the actual, there's like an actual connector that sticks out a little bit, so it needs a few millimeters of space. And then I tried to make this strong where it needs to be strong. So like if you think about where the forces are going, that's where the section analysis is pretty handy. So here, in fact, I already had the section that I wanted. Let's just turn that back on. So this is like a cross-section of, you know, basically right where the center of these M2 mounting bolts go. And so this is kind of the important part where, I'm kind of grabbing around the shaft of this screw and around the shaft of this screw and having a rigid connection there. So this area needs to be strong, this area needs to be strong, and then it helps to have a good connection between the two at the tops and the bottom, but then the middle here is open. Let's see if we can, well, at this point it's probably easier to just look at it in the 3D printing software because this gets you a section view pretty naturally. Yeah, Kenneth in chat says, section analyses always make me feel so professional and cool. I agree. Yeah, they definitely seem pretty nice. It also reminds me that I'm using like a solid modeling tool and not something that thinks about surfaces really. I'm still really used to thinking about surfaces. So, and then we can look at how this prints. So, using the brim this time, you would think I would learn my lesson, and every time my print fails because I don't use the brim. So then, a nice little base here. Then we start carving out some slots. And a space for the screw head. And then I kind of made this a little wider at the top because there's room for it, and I figured some reinforcement there would help, especially given, otherwise there would have just been a couple of layers holding like this and this piece together, which seemed like a problem. So this is probably pretty strong on its own, but we have an option to also glue this to the camera body because, if I use these screws to attach it and then like also epoxy it, then the bracket doesn't really need to come off the camera. I can use these screws to get it off of the gimbal when I need to. So I think that's pretty much that. No, that's not the camera I wanted. There we go. All right, so I'll do the TV cooking show thing and take the one out of the oven that I printed earlier. Oh, actually, can I get to the time lapse? Because I usually have a. Can I get that easily? The Octoprint server generates time lapses automatically. Is it going to be easy to find? Here we go. I have an rsync script that will properly file all the time lapses that the printer has made since last time, but I haven't run it recently, so this is just off of the server. Can we loop that? How do I loop? Loopy loop loop loop. Oh, do I want to push that button that's behind the thing that you can't see? Yeah, okay. That's slightly amusing. That it's a time lapse of a tiny thing printing, That's not the camera I wanted. Okay. So here it is. So still got the brim on it and everything. Let's clean this up a little bit and put it together. So besides actually just assembling stuff, the next thing that we actually need to do, so I still haven't actually drilled the holes in the camera. And before I start making permanent modifications to either the camera or the gimbal, I think the one thing that I would like to still test to have some assurance that this is going to actually work is to get my SDI signal running over the micro-coax successfully, since I haven't actually seen that work. So I'm not that concerned that it won't work, but it seems worth testing before I start cutting into my camera. But we can take a quick look at how this fits together before I actually do the drilling. And then for the drilling, my plan there is to just go back into the CAD software and export a drawing that's lined up with the surface of the camera housing, and then just print that and stick it onto the camera, and then take that over the drill press. The brim is really tenacious when printed with this material. So this material is a T-glass. It's spelled T-G-L-A-S-E. How do I even ever focus this? And it's made from PET, so like water bottle plastic, basically. And it's pretty strong. It's interesting in a lot of ways. It's optically fairly pure, at least as far as things that you 3D print go. It's strong and tends to not break, tends to not really be brittle. It tends to bend. I used this for some load-bearing pieces in like a sculpture thing that I did, so I was like, that same luggage scale actually, I was making brackets and testing their braking strength and making sure that I had plenty of headroom and that kind of stuff. Man, it's difficult to keep that in frame when I'm not actually paying attention to the monitor. This little slot probably needs to be... I had to, well, so I've already test fit one previous iteration of this, and I had to carefully clear out the corners of this slot to make sure they were square before it fit. See if it fits. A little narrow. Doing this and getting it on the camera is trickier than it seems like it should be. It's actually easier when I'm working on the microscope because then I'm looking at the same monitor that you're seeing. Yeah, I feel like, oh, so with the coax, I haven't decided which coax to use. We should take a closer look at the options, but, so after I decided that, we weren't going to find 75 ohm micro-coax and delved into the world of more widespread 50 ohm stuff, there's this 0.81 millimeter coax, which, so I don't know if it has like a real standard name, like, most coax has like an RG designation or something like that. This coax is, I think, basically the same stuff that you find sold with the Hyros UFL brand connectors that everybody uses on like Wi-Fi cards these days. I think it's the same coax, but usually, like if you go to buy that coax, it's like, I haven't seen it sold as like a separate thing usually, but then I found on eBay you can just search for it as like by outer diameter, and if you search for like literally 0.81 millimeter coaxial cable, then you find that stuff. So I got some, and that's definitely one option. It's a little bit thicker than the single wire that I'm going to be replacing, but not by much. Then another option is, I went and found this stuff on DigiKey that's just like the thinnest I could find, and so it might even be just like overkill for this, but it's 42 gauge coax. It's really little. I measured it at 0.32 millimeters diameter, so it's really little. It's smaller than the wire we're going to be replacing. It's nice and flexible. Both of those are going to be annoying to work with, but I'm sure the 0.3 way more so. But I guess my main question at this point is which one is going to last longer in the gimbal. You know, is it better to have something that is small and has a little bit of extra wiggle room, or is it better to have something that has more material in it so that there's more stuff to kind of, you know, last as it wears away? Does this fit? Yeah, great. I remember which orientation this goes in. I'm putting this on upside down already. It's this way. It's symmetric at least, but it's a tight fit. There is like a little bit of a non-flat kind of curvy lip on this, I think, from the 3D print. You know, like material building up at the corner very slightly as the printer tries to round the corner, I think. Anyway, this bracket feels pretty strong. Oh, that's nice. Can we make sure this is actually focused? Okay, so that's the motor housing, and underneath this cap is the accelerometer, gyro, whatever, IMU chip that they're using. The wiring, including the new coax, would be passing through there, through this cap, through this hole, and then through all the rest of the joints in the gimbal. And we've got holes for, where are they? Oh, let's pilfer the wiring from this other. So I already started to assemble the previous iteration. This one was before I realized I needed all that extra space for the connector, so this doesn't have enough room for the wiring. Let's steal its M2 bolts. And coax. Yeah, and they're both pretty flexible. Oh yeah, I don't remember off the top of my head what the price was for the DigiKey cable. It's definitely expensive. Or for the, you know, the stuff I got that's the 0.3 millimeter. But I didn't get very much of it. I just got like 10 feet of it. But even that was, you know, I think it was like 40 or 50 bucks or something. So yeah, I mean, I'm not planning on using much of it. And it does seem like it's probably overkill for this project. The stuff that's, I don't know, I'm not sure what they would be using in like a laptop hinge. I've certainly taken apart older laptops where it looks like it's basically the 0.81 millimeter kind of UFL style cable. And yeah, I don't know. I mean, more recent laptops might need something smaller. Oof. This, come on. Quite. There we go. Didn't quite see what that was even stuck on. Let's also thread this wiring harness through there. So this, I tried to measure this so that it would have room for this whole connectory thing, plus some coax like running along one side of it. Well, we don't actually need all these wires, we just need 2 of those wires. But this plug, we kind of still need the plug. I mean, we don't need the plug, but it would be convenient to keep the plug. So that... goes in there. And adding tiny coax is also something I figured would be super useful for other projects. Like, if I was only planning on using it for this, I don't even know if I would have gotten 5 feet, but having some of that around for the reverse engineering projects seemed super useful for like clock signals in tight spots. So that's what I suspect I'm going to end up using most of that for. Okay. This is still kind of tight. I think I want to make this less tight so I don't damage the wires. I'm just going to use the sanding sponge on these corners, which is probably what I should have done to begin with. I've also seen this kind of coax in, or at least something that looks very similar, in like microphones. I guess the first thing that comes to mind is actually in the Nintendo DS, but I'm sure I've seen this in cell phones too. When they even need a cable for what they're doing. I always get confused about which direction this goes on. So the bump, I think, goes on the same side as the motor because the flat side needs to go toward the camera, which is not toward the motor. There we go. So this wire will then just kind of snug around over there and then probably just solder directly to the board on the camera. And this is kind of a placeholder, so I'll end up having probably just 2 conductors for 12 volts and ground, and then the coax for video out. And then when if I need to access the on-screen menu for the camera, then I can plug in that little connector from the original wiring harness. But I won't have that connected when the thing is actually, in flight. As it is. I was going to make a, well, I probably should still make a printed drilling template, but I'm sure I could just also get away with using this as a drilling template. But, I'd do a better job of actually getting things centered on the camera if I print and glue a drilling template, I'm sure. Man, these M2 screws are really adorable. I haven't really designed anything with M2s before. Everything's been M3 and larger. Mostly M3. M3 is a good size. I think I was inspired by all the M3s in the MakerBot kit that I assembled. And I just designed a bunch of stuff of my own using similar hardware. Is this going in? Oh, there we go. There's a bit of 3D printer crud in the hole that I just pushed through. Oh, interesting. Ben mentions that they have a Dell XPS 13 and it still uses the larger kind of cable. I assume they mean the 0.81, so neat. Well, that seems like, the 0.81 definitely seems like a good starting point. I could save the fancy micro-coax for fancy reverse engineering projects. So that's those 2 screws, not like super, super tight, but reasonably snug. And then on the other end, I've got these screws that I'm stealing from an earlier iteration. Also, I have some SMA connectors that I can terminate one end of the coax with, the end that goes into the amplifier, presumably. And then on the other end, I think I'm just going to have to solder it to the board, which is not optimal, but I don't even know what kind of connector the thing is using. Like, it's something I think I've seen before, I just don't know what it's called. I could also try to take the connector off of the wire that it came with and reuse it, which seems a little nasty, but maybe doable. Yay, this is nice. This bracket's making me happy. I think this is going to be strong enough. I mean, maybe unless Tuco attacks this thing, but then all bets are off. You know, I'm sure he could, I mean, he could kill me dead if he wanted to. That's a good question. Ben asks if the board designer maybe put a footprint that I could reuse for UFL or something else. That's a good question. I don't have any like bare UFL connectors here, but I'm sure I have something I could desolder one from. And it might even be close enough to what's on the board, because they're like, we could take a look at it, because that's a really good question. That would certainly save some annoyance. So yeah, that's pretty nice. Feels pretty solid. And the wiring is pretty happy. So then this would end up going basically right there. And that, you know, the nut will be a little bit in the way of those standoffs, but I think they'll still be accessible. And I can certainly use, like, the standoffs are optional. If I can't get the standoffs in, then I can use M2 screws there, and this is still plenty of room to get a wrench in to access those screws, I think. So I'm pretty happy with that. So yeah, so okay, as much as I'd like to do the drill press, let's actually test the coax. So let's see. Let's have our coax models out here. Oh yeah, I have some actual coax with a UFL connector on it too. Actually, maybe we should just look at the circuit board, because like if we are using 0.8 1mm coax, and if we can get away with resoldering, you know, replacing whatever's on the board right now with a UFL connector, then like I can't use this as is because I have to get it through the gimbal, but I could at least cut off this end, re-terminate it after I feed it through, and then, you know, use the end that's really hard to get on there, you know, from the factory. Do I only have one size of these, or did I get two different sizes? These are both 30 centimeters. Yeah, so these are, and like these are easy to find and inexpensive because they're just designed for, you know, you have like a Wi-Fi card in your desktop and you want to get it to an external antenna. They also use these inside some Wi-Fi routers, so pretty straightforward. But yeah, let's take a look at the circuit board and see what the coax situation is there. Ben asks if there's any chance I could just put a hole in the camera and mount the SMA somewhere poking out. Well, I mean, I could do that, but having an SMA on the camera doesn't do me a lot of good because then I've got to still do something with the wire. And the problem that I was facing was that, you know, having this wire hanging around outside the gimbal, you know, at least with the thicker coax was just a non-starter. With the thinner coax, maybe it's fine, but it would be nice to have the wire more protected. So like this is the wiring harness it came with. Oh, I'm spacing out on the name of this coax. It's something standard. I think it's like RG168, I want to say. What is its diameter? It looks like it's about 2.5 millimeters. 2.7, 2.6. So yeah, this is really common. I've got a lot of this stuff around. This is what the SMA connectors, like SMA cables, usually have this coax. Oh, and micro-coax in chat is saying that there's like 1 billion Chinese camera modules that do USB or Ethernet connections. Other SDI ones as well. I mean, I've seen camera modules that have all sorts of different connections in similar form factors. So yeah, I mean, this seems to be a pretty common size camera board. Like looking at this camera, like disassembling it, you're left with like a pile of Legos effectively. So I'm sure the manufacturer builds this by combining a lot of things together that are designed to go with each other. Anyway, so I don't know what this connector is called, but it seems like maybe something I could pilfer. Let's look at the board end on the microscope. Well, so the connector, first of all. Little pin. Dielectric is kind of sunken back. Looks like I might be able to reuse that, depending on what the termination is like. Oh, the sensor is so pretty. I like how you can see, oh wow. So you can see that black masking over the kind of non-active part of the sensor, but you can also still see, when the light hits it just right, you can still see the circuitry in that area. That's fun. And a lot of power supply goodies. So that's the back side of the SMA, or not an SMA, but like whatever that connector is. So it's not surface mount, it is like a little through-hole connector. There's the system on chip for this thing. Magnesium. And the little connector. Yeah. I mean, I'm not really that worried about having to solder to remove the camera, because like that also, like removing the camera is not going to be easy anyway, and that's fine because this camera is effectively going to be part of the gimbal. But the other thing I'm keeping in mind is I want this connector to still be accessible so that I can plug in the little joystick controller thing if I need to. And this is also the connector that brings in power. So that means I either need to put another power connector on here or solder on power. And so it might be easiest and lightest just to solder on the power and the coax. So I don't know, there might be something else, but... Oh, neat. Mark in chat says this is probably an MCX connector. So that's interesting. I had not heard of that before, but that is good to know what these are. And yeah, as for soldering, like also soldering coax to a PCB is not the most amazing thing ever, but it seems like I could probably put the middle conductor through there and then just solder the shield as close as I can to the circuit board, and that will probably be fine. So, I mean, I might even also just use this connector as a solder cup, basically, so that I get this as a shield, which is a little nasty, but I don't think I'm going to be reusing this connector. So, oh yeah, and micro-coax in chat is lamenting that these chips are not easily open to programming, since there's probably some interesting silicon in there. Yeah, that's a thought that I've had as well. What's under there? I don't really want to pull off this heatsink right now, but there's probably an interesting chip under there too. One of these is probably, like, I don't know, there could be a bunch of different things. Like, there could be some combination of imaging system on chip, SDI transmitter, RAM, general purpose processor kind of system on chip. So I don't know. A lot of things could be doing in there. Anyway, I think we should actually make a decision about the coax diameter. Let's just try getting the 0.81 through the hole and see if it fits with enough room to spare. Oh, the cat's looking good over there. Okay. Actually, maybe we do want the microscope because coax. There's these two, and oh, this one and this one. Okay. Do I have that tiny piece that I was already mangling? There's a little tiny cut end off of the fancy coax that I already tried stripping. And now I can't even find it. It's like looking for a surface mount resistor. Yeah, that's lost cause. Alright, so this is a UFL connector like you might have seen on Wi-Fi cards, covered with cat hair. Let's get the cat hair moved elsewhere. So it's kind of cool. Magnified like this, it kind of looks like something you might use to power your flux capacitor. Looks like it's all crimped. There's an outer crimp for mechanical, then there's like a shield crimp right next to it. Can't quite see how the middle connector is in there, but I assume it's crimped also. So then this stuff, oh, this is even a little bit thinner actually. So the gray stuff on the left was sold as like a Wi-Fi cable, basically. Like, this is what you get to attach your Wi-Fi card. The one on the right was what I got when I bought generic 0.81 millimeter diameter coax on eBay. Can we get this in here for comparison? Let me grab something else for comparison. Alright, so this is like the SMA cable. This is what the camera has in it right now. And then we've got the Wi-Fi cable, the 0.81 cable. Oh geez, and then there's this stuff. Haven't actually taken this off the spool yet. Yeah, this is like sewing thread. Coax. Yeah. So that's quite a difference. So that's the 42 gauge micro-coax next to the 0.81 millimeter. don't even know what you'd call that. I think a lot of people would still call that micro-coax, but next to this stuff, it looks enormous. And then the other point of comparison, I guess, is the cabling that's already going through the gimbal, since that's basically what we're replacing is one of those. So here's that wiring. So the micro-coax would be way smaller, and as you can see, the other coax is a little bit bigger. So let's see how that feels, just putting the larger coax through the gimbal and see if that seems to still be moving smoothly. Because yeah, this stuff is pretty awesome, but probably way overkill for this project. This will go into my bag of tricks for PCB surgery. And so I guess that kind of rules out using these like Wi-Fi style adapters, because even if the connector was convenient, which it isn't necessarily, it's a little bit thicker, which is like, it's already maybe a little thicker than we want it to be, even the 0.81 millimeter stuff, and this is not moving in the right direction. And this stuff just looks enormous now. So, that is our joint. Yeah, I haven't really poked around in there much to see what that lubricant is like, but it definitely looks like there's some kind of grease on the wires, which I might end up needing to reapply some of that depending on how this goes. But I think, oh man, what kind of foreplay do you even do for this move? That looks like there's plenty of room, doesn't it? And so the other gimbals in the stock configuration have one additional wire, but I'll be removing that and replacing it with this. So I think we're good. And everywhere else, like, it's kind of tight, but I think we can deal with it. I think this wire is going to fit just fine. Kenneth is trolling me in chat saying it's pronounced Gimbal. No. This gimbal is going to have a high-tech cat hair composite lubricant in it when I'm done with it. Hopefully it won't be too big of a problem. Alright, so maybe, because I don't really want to cut this cable right now, since not really knowing exactly how long it needs to be, but maybe just to make myself kind of a worst-case test scenario, I'll just try terminating both ends of this length of it that I have, and we'll see if we can get some SDI video running over it. This isn't that long. How long is this? I think this might be like another 10-foot length or something, but this one was not as expensive as the DigiKey 10 feet. This is like maybe even just 6 feet, so. Oh, this is pretty nice and flexible though. Like, I don't think this is gonna have trouble in the gimbal. So for terminating this, my plan was going to be to just kind of temporarily tack it into these kind of solder cup SMA adapter, or SMA terminations, which I think they're on the other desk. I'll be right back. Where are you, SMAs? Oh. I think I already brought them over here. Tuco. You being a cat today? I wonder if Tuco can help me. Oh, here they are. They were so handy. I missed them. Hey, beautiful tiger. Are these all the same, or did I get two different kinds? I think they're mostly the same. All right. So here are the terminations I have. You can see there's a spot for the crimp to bite down on the shield, and then you solder the interconnection there. And then there's another piece, which I may or may not use for this temporary job, but there's a metal shield that fits over the cable and then crimps down to mechanically secure it. But this is all designed for like that larger cable that is like astronomically huge for what we're doing now. So I don't know if it's even going to make sense to use that. I might just like tack solder the shield down to this, or otherwise improvise something. I mean, what does it look like trying to put this on the... Yeah, that's a little loose. Just clear off some desk space and strip some of this coax. Get the cheesy porn music going. I don't know of any like automatic tools that can strip stuff this small. Like, I have wire strippers that go down to 30 gauge. I have like a coax stripper that works on really big coax, but I suspect that anybody who makes a special purpose tool that works on stuff this small would be selling it for way more than I would want to pay for such a thing. Let's just coil this up a little bit so I don't kink it too badly. Oh, Kenneth is suggesting a thermal stripper does okay with this stuff. Thermal stripper. I mean, that sounds nice. I don't actually know what a thermal stripper is, but now I'm imagining just hitting it with my hot air desoldering tool and seeing how far that gets it. I mean, usually my approach with this stuff would be to just like scrape at it with a sharp knife. Let's use one of our earlier 3D prints as a cutting board. Oh, that is not a flat surface. Maybe not that print. Or maybe the other side of it, at least. Let's also not be shorting this out all the time. Unplug the power supply. Ooh, that's insulation's nice and soft. Yeah. Thermal stripper, okay. Maybe I'm gonna have to look up what a thermal stripper does in just a sec. But rotating this wire while holding it down was proving to be less easy than I expected. Yeah, now I'm imagining soldering that even smaller coax like directly to a via. Now that would be fun. It's like, oh man, that's my That's my chip select or something. That's my SPI clock. I'm gonna run that at 500 megahertz. I can't quite just pull it off still. I need to cut the other side. Kenneth is helping out with the porn music noises on chat. I appreciate it. There's probably some YouTube copyright bot safe porn music I could put in here. I don't know, so far I have not dipped my toes into the elevator music archive, but maybe it's got some good stuff in it. I mean, I really appreciate other channels that do original music, but, you know, I also understand that, like, a lot of people get some good mileage out of the stock music. That just hasn't really been my style so far. Okay, so I think at this point I want to push back the shield. Probably a better way to keep the shield from getting really messy here. Micro-Hex says that the music archive has plenty of Incompetech music. I can believe that. I mean, I'm sure if I wanted something pretty generic too, I could just like grab some like default loops out of Ableton or GarageBand. I mean, I could also make something. So far, most of the music I've tried making has ended up being pretty weird, which is fine, but harder to use for just like background music. Is there anything I have that would do a better job at stripping this thing? I really don't want to cut this in half. I'm like filleting the wire. Hey Tuco, I feel you on my leg. Are you going to help me with this wire? Let's try to rotate this and fillet the other side, and then maybe we'll actually have some exposed copper. Or silver, or whatever this is. Aluminum? I hope it's not aluminum. Might also be better to use a fresh knife blade for this. Fingernails to the rescue. Okay. Andrew says in chat, if I were to grab some default loops from Ableton, I could become a famous EDM artist. Yeah, clearly, well, so actually, I'm so close to just being able to, like, I'm literally running Ableton right now already to do the audio for this stream. And so, like, it would be pretty easy to throw some of my own bits of music-y stuff in there if and when I wanted to. It's been on my list of future stream improvements, but so far hasn't really happened. But yeah, maybe that'll start rising in priority. Let's find a way to hold this, maybe. I might screw it into a SMA coupler, or, oh, here's an SMA jack. If I screw it into an SMA jack, then, because like I can hold on to, I could clamp onto this outer section, but then the inner section is still free to wiggle unless I have it actually screwed into something. So in this case, I think I can just clamp the whole thing. Let's not do that under the microscope because that's hard. that is still kind of not the sturdiest work holding, but let's try to deal with it. Let's not put that over there. Put the lens somewhere where if it falls, it doesn't have far to go. Yeah. Okay, maybe maybe a circuit board with an SMA on it would be a better choice. I'm gonna grab something nearby. Let's have some cat. Just use another one of these little low noise amplifier boards. Also eBay special, but quite handy. This is the same one I was using in the PLC glitching experiment to listen closely to the processor. Hey, little cat. Meow. Gotta do the important things. Hands are still wet from washing the cat food, some stink off of them. I love Tuco, but I really hate the way his food smells. But he and I have different food tastes, which is totally fine. So that's what we're dealing with. We might need more of this stripped. Yeah, well, it looked so giant under the microscope, but really, geez, I need like that much of it stripped. So like down to there. This works all right if I can get the cable at just the right angle on a really sharp part of the knife and then pull it really gently. Then the insulation just cuts really smoothly. And I nick the wire a little bit, but I think it'll be fine. 4757 in chat says, oddly enough, I just opened a different brand of dog food today and thought it looked and smelled really close to something I would eat myself. I've kind of had that experience too. I mean, I don't eat meat, but I've definitely had some stuff that I've given Tuco that seemed like totally legit food that any animal, human or cat, would probably find totally appealing if they ate meat. But yeah, generally Tuco's not super into my vegetable diet, and I generally am not too into Tuco's animal diet, but you know, we each do our own thing and it works out pretty well. Where did the end of this go? This is just a mess now. It's mildly satisfying. Ooh, neat. A micro-coax in chat is working on a smartwatch that might end up needing 0201 surface mount parts. Pretty little. Let's see how this compares. Okay, depth perception fail. Alright, well, I think I basically want something like this. And I can just bunch up the shield over here and then either solder or crimp as appropriate. So let's just tin these things and solder them. Let's use the little soldering iron for this. Oh man, maybe it's beer o'clock. Ah, delicious little solder pencil. And some solder. Tuco's hanging out near the window. I would go over there and move the camera, but usually when I do that, he just moves when I get close by, because he sees it as an opportunity to get my attention. Alright. See if I can just stick these two things together. Alright. And as for the shield, I mean, the crimp is not really going to do any good for this wire diameter, so I'm going to try to solder the shield. Don't know if that's going to work. Well, I don't know. Maybe I can get the crimp to work. Kenneth is excited about the micro soldering handpiece, which was totally a gift from him. I appreciate it. Yeah, it's been super nice, especially for stuff like this. Well, I kind of want to use a little bit of solder there. This is maybe time for a larger soldering tip, though. Not much there, but I'll put a little solder over here, too. Well, I should do this for real with a bigger soldering iron tip, but this is probably enough for doing a quick test. Oh man, YouTube has been flaky about notifications. I'm sorry about that. That really needs some strain relief, but like I said, this is a quick test. I don't want to make this permanent quite yet. Right now, I think I just want to put 2 SMAs on this, and then put it in line with the cat camera as a test with some SDI video. But then I think the next experiment would be, well, at that point I know the cable's fine, and I think I'm just gonna like start assembling it for real. And I think I'll be terminating one end like this, but you know, a little bit less temporarily. And then the other end, I'll probably just solder to the PC board in the camera. The connector is super heavy. Alright, let's get the other end over here. And maybe not skimp so much on the stripping this time. Where did I just put that SMA? Maybe I hadn't gotten a second one out yet. Alright. I really like all this machined brass. It's like a good reason. And you think anybody gets into RF electronics just because of that? Maybe a better reason to get into clock making or something. another shout out for a somewhat off-topic YouTube channel that I like. ClickSpring is pretty awesome, especially if you're into machining brass. Let's maybe take off generous-ish amount. I have to look into this thermal stripper thing. Yeah, there's got to be a better way to do this. There we go. Yay, fingernails to the rescue. We can just push this back. My tiny PET plastic cutting board down here. I think I'm stripping a little too much off the very end, but it's not a big deal. Okay. I think I lost a few strands there. No, that'll still be solderable. Solder. Don't stick to my soldering iron just yet. It's like I need to tape this to the desk, or just to anything that's a little bigger. All right, tinned. It doesn't actually have the girth to actually make it around that. I'll have to solder it. Oh, maybe it does. Maybe I can tease it apart a little more. Tuco's climbing around behind stuff now. I don't know if this is gonna work. I mean, I could say that about pretty much everything. Oh, those are Tuco's favorite birds. Oh, can I get the camera on him? He's being super cute. He's behind the curtain. Oh, maybe I can't get it on him just yet. All right, this is another tack-worthy joint, I think. Maybe a little bit of solder on the opposite side. Let's put a little solder on this side at least. In chat, Kenneth is discovering that a common side effect of building like arc reactors and shit at home is people assuming you're Tony Stark. Alright, that is not a great joint, but it'll work for doing like a really basic proof of concept test. Warm, 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 very warm, great. Well, maybe if Tuco's not going to be on the camera, I'll bring the camera over here and use it for a test. So I think the first thing to do is to stick this in between the camera and this SDI splitter here. So, Alright, so this will give me a couple tests. So this is a splitter. It, I think, has an amplifier but not a reclocker in it. So if this cable kind of degrades the signal to some extent, we might end up seeing, you know, the monitor, like the stream machine, is getting this over a long wire. So that would be showing problems sooner than this monitor. So that might give us some extra data points. There's that. A couple of SMA to BNC. I think this combination will work. So SMA coupler to male BNC, plugging in where that was attached, which also has its own little chunk of 75 ohm cabling there. I mean, if this doesn't work, there could be a number of reasons, but we can start taking out cables to see how bad the problem is, or even start looking at it on the scope and see what the eye diagram's like. Alright, and then this on the camera to get us SMA. Alright, so now for a control test, let's just connect a little SMA cable between these two. I guess it doesn't have to be that little, but at least something that I know is probably good. So like just a plain old store-bought RG. I think this is, I keep wanting to call this RG316, but I don't know if I'm remembering the number right. So there's that, and then you get video? Yeah, great. So that is video going over this wire. So now let's try our really little coax and see if we can get anything through there as a smoke test for this plan. It's so little. Hard to get this lined up right. There we go. one end. So I think this is 10 feet of 0.81 millimeter 50 ohm Wi-Fi cable with kind of shitty terminations. Oh, that's a good sign. Yay! I think we are on our way to Gimbal Town. That video is going over this little tiny thing. I mean, if we were getting degradation at this point, we'd be seeing like snow on the picture, but we're not, so we're not getting a bad enough signal to be actually losing any bits that are noticeable. Did I see Tuco? Yeah. Tuco cam powered by tiny coax. Okay. Well, maybe I'll put the cat cam back and we can start building this into the gimbal. Hey, buddy. Gimbal Town. Do you want some bolts, little cat? Let's take this cable off before I break something. These little inline BNC jacks are sometimes really loose and sometimes really tight. There we go. I think that was what I wanted. Yay. Enthusiastic success. Chico's hanging out in that same spot over there. I think he's watching the birds. Crotch cam. Hey, Tick. All right, let's start. So I think the next step now is making the drilling template so we can actually drill into the camera. Computer time. What do you want, Tuco? I mean, I say that in the most lovingly way I know how when I'm slightly annoyed. Maybe he wants to play. I think there's a surplus of free bolts roaming around here. I need to go, like, sweep them out from under the refrigerator or something. Hey, Tuke, you see any bolts, honey? Oh, here's one. You can do it. He's gotten better at that hammock. I think he's got this under control. What do you think, Tuke? What a good little beast. Doing the beastly thing. Hey, Took. Oh man, I'd throw it, except I can't quite reach it. Clearly another job for a robot. Oh, yeah. Yeah, basically the thing with following around the cat with the camera, that's pretty much what we're engineering here. Which goes, I mean, I keep having this problem where I'll have this great idea to make some bit of apparatus to automate my experience with my cat, and then I'll end up in the moment faced with the decision between like actually playing with my cat or like doing CAD models for this thing that might eventually play with my cat. So that that often slows down those kinds of projects. But it helps to do that sort of thing on stream because that keeps me a little more focused. And you know, it's nice to be able to turn these things into videos. Hey, Took. Did you find one? Oh, it's way over there. He just pounced onto the hammock again. Okay, so this next step should be easy. I just don't quite know how to do it, so it'll take some Autodesk fussing. So basically, I just want to make myself a drilling template. So like these wider holes on the sketch, basically. One tricky thing here is that things aren't quite axis aligned because this box has a slight draft angle to it. Hey, Took, where is it? So, but this sketch is already basically what I want. So if I can export this sketch as a printout of any kind, then that's basically what I want. This sketch 6. Save as DXF. I guess I could do that. That's not necessarily the easiest format to do this in. I mean, I could make a separate document, basically. I could also just do this in Rhino. Let's... I guess I don't know what the options are for printing in Autodesk, and like whether I need to line things up with a particular axis, or whether I can like print stuff from a plane, or whether this program doesn't even print and I should just go into Inkscape or something. I'm gonna go into Rhino because I miss Rhino, and I think I can do this pretty easily in there. Load. All right, import. All right, that's the basic shape. How did all that extra junk work? So that outermost shape should match the camera. The innermost shape is basically the opposite side. And these circles are really what we want, but we want to make sure that those are easy to drill. So these inner circles, we don't want those. This was some construction geometry. All of that is unimportant. That would be useful for reference. Leave that there. And then this line is useful because that'll give us center points for the drill. Crosshairs would be nice too. Maybe I'll add like lines going the other direction. All right, so that's my drilling template. That's all there is to it. And in Rhino, printing works using whatever your current camera is. So I want the top orthogonal view before I print. What is that thing on the bottom right that seems to be... Ah, that is a double line. I guess that doesn't really matter, but we can clean that up. Print. Top. Scale. All right, 1:1 scale. And I don't really care where it is on the page. This will waste a lot of the paper, but I don't care that much. Printing. Well, this is giving me a PDF. I guess I could have printed that directly to the printer. Why? I guess it's trying to open this in Acrobat. Yes, I don't want Acrobat. Well, fine. I don't know if I have the print driver installed on this machine, but if I don't, that should be quick. Either way, I've got a PDF. There's my actual printer. Okay, it just wasn't default. Let's see if that actually matches reality, and then we can start cutting. Oh, my cat really likes the printer. I wonder if he's going to notice. Oh yeah, there's something else I wanted to do on the computer. Just for reference, I wanted to quickly look back at how the gimbal was working with the other camera. I think this was the file. No, that's not useful. Oh, I thought I had this already queued up, but I guess I lost it. Oh, this is the one. The right trigger mount to the third channel, which is mode select. Let's mute that. So yeah, a lot of this is symmetric, so we could mount things in other orientations, but I want to make sure that we mount this the way the firmware is expecting it to be. So motor, with it looking toward us, motor on the left side. So I'm going to go ahead and put a piece of tape on the side that we're not cutting, just so that I remember that. And then the other side will be free. I'll glue stick the template down to the other side. All right. Can end this. No, two goes by the printer. You know. For your safety, we have automatically stopped the recording. So also of note, the screws go toward the back of the camera housing because they want to be above the circuit board, not below it. So this is the orientation we're going to have. I'm going to get scissors and a glue stick. Maybe not a glue stick, maybe Super 77. think I trust glue stick to hold this down while I'm drilling, so I think it's worth Super 77ing it. Spray adhesive. Let's cut this out first. To cut this pretty much right on the line, I guess. It'll be easier to line up that way. And I mean, these dimensions are not super critical because, you know, it's not like any of this was super well balanced to begin with. Mostly it's just going to keep things, well, it'll line it up kind of in one axis. But a lot of this centering is only really necessary for aesthetic and for kind of best effort center of gravity. So there's our little piece. This goes just like that. Yay. Cool. Well, let's stick that down. Nice of whoever sends these out to send me all this free overspray protection. Because this stuff is a mess if you don't have overspray protection. Nope. Speaking of messes, let's not have that blow all over the place. I think now it's sticky enough that it'll hold itself down. Oh geez, that might be too much. I'll just screw this up in every possible way. It'll still be fine. Yeah, I put too much adhesive on that, but it'll do. No. I mean, I've got the wrench over here now because that arm has been breaking down so frequently. So I can actually take it apart without interrupting my workflow too much. Alright, there's my drilling template. Might be a little more stuck than I really need it to be, but it's fine. We're talking about lacquering and adhesiving ads in the chat. Yeah, you could probably take junk mail ads and just stick them to anything to bring, you know, to send some kind of point to somebody. Alright, I think it's time to go to the drill press. Get this stuff mounted up. Let's see what camera setup to use for this. Can I move this any closer? Some extreme lighting. Always looking for the cat. So we decided on a 9/64 hole to be a pretty generous clearance for an M3 bolt. Oh, there's two now. That's better. It's a good spot for him. Okay, vice time. Some good layer of cat hair dust on my vise. Really only have one way to grab this with the way the taper is. Get that pretty straight up and down. Maybe. This plant is overkill. Table set at the right height and centered and all that. That's about right. Clamp this somewhat, but for the not moving around. go for that hole. There's my safety glasses. There they are. These are the ones that don't fit over my glasses. These. Sure, these work fine. All right. Would help if that was plugged in. Got a long chip on that one. Whee! Yeah, that was easy. Definitely nice soft aluminum. This will be easier with either, I think I usually use a vice grip clamp for this. I was just too lazy to find it. I mean, bolts would also work pretty well for this. I also don't really own a center punch, which is one of those little things that was like, obviously I should have one of these. So I've got one on the way, but it doesn't help me right now. Measure thrice, cut twice, something like that. Alright, wow, that was even faster. Produce nice soft metal shavings that won't dig all the way into your foot. They'll just kind of stick there for good measure. Yeah, nice. I think we just gotta take off that cutting guide and deburr it a little bit and we're good to go. Also, don't have a proper deburring tool, but we can make something up. Gonna sweep up any big chips. I don't see any big ones. A couple of little ones. Anyway, great. Back to the desk. Oh yeah, kind of says walking around in this shop barefoot is a pretty confident move. I mean, confident is one word for it. I've certainly had plenty of things in my feet, so I don't recommend it. It's just that I like walking around barefoot, so I kind of factor that in. But yeah, I've had plenty of metal and bolts and other things in my feet over the years. All right, this thing. I do also usually try to keep metal shavings out of the place. Like, I'll sweep up after doing a bunch of fabrication usually. Right. Oh, that's a nice mess. Let's get some scrubby action on this. Hey Tuco, you're over here now. Oh, camera. Cats. I don't know, having bits of metal in the foot is not fun. I have to say bolts are pretty bad. Like, they're only plastic, but it's kind of like stepping on Legos. So I generally try to just have a background thread watching out everywhere I put my foot down while I'm walking because of the bolt thing. But it doesn't really work if I'm distracted or it's really late. That took off the burrs too. Cool. So where's our little bracket? That's the old version that I was using as a cutting board. Here's the new one. Oh. That's great. I'm enjoying that. Focus. Yeah, so I'm liking that. Should be room for the circuit board and everything else. So, what's next? I feel like maybe the gimbal mods are next, like actually running the coax through the thing and doing the 12-volt power mod. I mean, let's go ahead and see how assembled this gets nicely. I'm just going to put some M3 nuts on here. I think in reality I probably would want to use lock nuts or a little bit of glue or something. But again, like, this isn't going to be getting a lot of vibration, but it will be moving around. Camera mount. Yay. That feels really sturdy. I mean, so I can get it to wobble a little bit in that direction. Which, I don't think that matters super much. I mean, if I needed to, I could probably reinforce it with like a bead of epoxy down in this crevice. But I don't think I even need that probably. This is seeming pretty nice. Let's see if I can get the circuit board in around these nuts easily. No problem. That's nice. And these standoffs. There's a little bit of interference there. Enough that I probably don't want to use those standoffs. It's close. Like, if I gave myself maybe another 0.5 millimeter, it might have worked out, but I think I'm probably just going to want to avoid the standoffs. Without the standoffs, though, there's plenty of room there. But yeah, that's the camera assembly. Oh, Kenneth has a pro tip that there are correct and incorrect orientations for the circuit board. I was thinking about that. So I'm not quite sure where that would come in, since everything I've measured so far is square, but I certainly don't doubt it. I was thinking that this is the right orientation based on my remembering how the back panel assembled. Oh, it is actually upside down, because I was holding the camera differently than I thought, but yes, the camera's like that. This is up as far as the camera is concerned, so this is the actual orientation. Still plenty of room, but that's great. So that's where the coax is going to be going. It's actually pretty conveniently close to where the wire's coming in. Oh, interesting. Kenneth says that one of the rotations yields a whole bunch of, a shit ton of edge blur in the images. That's weird. I wonder if there's something about the, like about these little brass standoffs that they've calibrated in assembling the camera. Okay, well, I think that's all I'm doing here. I think maybe the next step is to take one end off of the coax that I just tested, and then start trying to reassemble the gimbal with the mods that I want and with that coax in place. So I'm going to put this camera board away again so that I don't damage it much. Oh, Mark is asking if I'm planning on enabling super chat for the live streams. I hadn't really looked into it. I mean, I kind of dismissed it as like, oh, this is just another YouTube feature I don't care about, but if any of you think it's something that's cool, I might look into it more and not dismiss it so much. Okay. Let's disassemble one end from this. Which end is the least good? Let's take this one apart since it seems to be already partly disassembling itself. Oh yeah, a few people in chat are saying that it would be really nice if YouTube replayed the chat along with the stream. I agree with that too. I noticed some people put the chat into the stream, and I was thinking about doing that too. A while ago, I had kind of decided to triage against that because I didn't think I had the CPU free to do it, but I'm actually going to switch to the larger soldering iron. Well, as I'm saying that, I'm thinking, like, the next thing I'm soldering is also going to be really little, so let me just stick with this for a sec longer. There we go. Yeah, I mean, I thought about putting the chat into the live stream, and I could certainly have a layout that does that. That might actually work out now that I'm streaming in 1080p. When I was doing the 720p stream, that was a little perilous, trying to get everything to fit. Slowly turning it while it's still warm. There we go. There we go. Oh yeah, Ryan mentions that Facebook replays the chat and it works well. I haven't used Facebook in ages, and I would kind of prefer not to. I technically still have an account, because sometimes it's useful for keeping in touch with the neighbors, but yeah, I try not to use it because I really don't like what they're doing as a company. But, you know, pretty much every tool involves making some decisions about how much of other people's overreach you can accept in your life. And so, all right, so we got the cable out. I'm going to cut off this kind of frayed end so that it's easier to feed through. There we go. So now we've got a fresh end on the coax. Gimbal Town. Okay. So for this, we're really just going to need to disassemble this gimbal significantly more than I already have. So far, I've disassembled the first and last joints, but this is going to require taking apart all the joints. Make a little more desk space. Okay, so we've got some of these covers. Oh, I should probably pay attention to which circuit board is going in which joint. I mean, this one is probably special because it's the first one, and this wiring harness goes to the little board that has the breakout for all of its inputs. I've already noticed that the other boards have some differences in how they're populated. And I only really need to make changes on this last joint, but I need to run coax through all of them, so let's see how minimally I can disassemble this. That piece. I'm trying to keep identical pieces together at least. This is like a nice little Lego kit with a bunch of identical pieces. At least you hope that the ones that look identical are identical. So far it seems like that's the case. Alright, let's try to separate these joints. Ooh, these screws are in tight. These aren't Loctited. Oh, there we go. That's fine. Yeah, on the topic of Facebook streaming, I've also been really turned off by how it just seems like there's this rampant thing where creators of all types just get their stuff yanked and put on Facebook. And then because Facebook is such a closed ecosystem, it's hard to even find out about this stuff most of the time. So creators don't really have much recourse to get that stuff taken down or to at least get compensated for it. Oh geez, is that yet another different length of screw? That's annoying. Figuring out all the screw lengths is going to be a little annoying, putting this back together. Most of them are self-explanatory. I guess I'm just going to remember that these are really little. So this might be the first. So taking apart the first and last joints, I didn't actually take apart any of these pieces where we're passing signals through the little channel with the sticker over it. I've taken these two screws out, and so now this is loose, and it feels like I could just pull that sticker up. Yeah. Oh yeah. Man, these stickers are nice. I don't know if I can reuse them. I'll put that somewhere. Well, that's definitely where my coax is going to have to live. Great. Oh yeah, also in the chat talking about the definition of a play is pretty weird. I think this might have been in the context of Facebook, but even YouTube, like, you have to watch very little of something for it to count as being viewed. Which, I don't know, that really depends on the content, I think. Like, it seems pretty subjective. Oh man. It seems like there are going to be a lot of ways to reassemble this incorrectly. Maybe putting a piece of tape to mark which side of this goes where. Because, yeah, I don't think there's anything to prevent me from putting this motor on, like, 1/3 of a rotation off, which would totally change where all the end stops stop. So, something like that. And these, man, everything just goes through all of these pieces, so I'm probably going to have to, I mean, just kind of keep all this stuff attached and then mess with the wiring harness, like remove the wire I want to remove and then add the wire I want to add. I feel like, well, if I ever have to just definitively answer a question about screw lengths, I do have all of this on video. These are nice and long, because these go through the whole kind of circuit board compartment and then into the motor housing. Plug. Alright. Should I label these circuit boards? I could also imagine having different bins for like joint 1, joint 2, joint 3. That might be useful. I just have to imagine these joints have different firmware on them, and I could easily reassemble this wrong. Just missing like a little thing that I can label these with. Let me get some white tape of some sort. Oh, and there's the cat. Joint 1. Which direction are these? Yeah, this is the last. So that is 1, this is 2, this is 3. If we're starting from the root, which seems like the way to start. Two. I'll put that on the circuit board once I actually open it. And then let's take the circuit board out of joint 3. So several of these have some silicone glue on it that I haven't taken out yet. This one's 3. So the difference I already noticed was in how these, there's like some 0 ohm resistors that route the signals to the connectors a little differently. Oh, there are LEDs on here. I wouldn't have been able to see those. I guess each of these has 2 LEDs on it, on the back. Maybe they have a different model where there's an opening where you can see those. Yeah, those little things with the pluses are LEDs. Yeah, see if I hold these both the same way. That 0 ohm resistor is on the last board, not on the first one. Another sticker. Another sticker, another ambiguously oriented motor mount. At least it looks like that opening is big enough for this wiring harness to fit through. Because like, I could understand them having to assemble the wiring harness around the motor bearing, because you know there isn't really much of a way around that. But also designing it so that you have to like snake the wiring harness through all these aluminum parts before you can assemble it seems like a bad decision. So I would be surprised if that's what they had chosen. Cat's charging, yeah. I agree. I think he's charging up for something, some awesome hunting. Alright, so let's try to mark which one of these is which again. Put some tape on the side that was actually pointing toward the bracket. And then, yeah, this seems like it fits through. So maybe I didn't have to disassemble these 2 pieces. That seems like I can just take stuff out from inside it. Maybe I can put the other 2 of those back together. So on this side, we have a similar arrangement here for joint 2. Got to unplug another one of these little silicone things. Well, another one of these little cables that are glued into the silicone. Right. Oh, interesting. This one has a black mark on it. Not like a burn mark, but like a Sharpie mark. I wonder if these are labeled as to which one is 1, 2, and 3 in some way. This one also has LEDs. Does not have that 0 ohm resistor in place. Label that one too. way so they aren't clanking. Yeah, what voltage does 2-coat charge at? I could see 2-coat running at 24 volts. Given how fast he goes, like I could also see him running on one of those 400 hertz aircraft systems. All right, so these two. Are these two the same? Oh, okay, these are different. So there's already two different versions of this this joint mount. This one is for the first joint, so it has these little ears to attach it to like a mounting plate. And then this one for the other joints is more plain. So this one I can actually just attach back to this piece because it doesn't need to be separate. Let's get the wire out. Yeah, that's handy. There's also, it looks like a little bit of tape. Is that sticky tape? Yeah, okay. Yeah, so it looks like there's some adhesive up here and then some like double-sided tape down there to hold the wire into the channel. So I might have to do something similar when I reassemble it. That was these little screws. All this M2 hardware. These have a bit of play in them when I reassemble them, because I'm just going to hold this like that so it kind of gravity centers. I had this job for a couple years working on basically, imagine like the lowest quality, cheapest spacecraft hardware that you can imagine. It was basically a little organization of some students and some like student staff members that were basically paid as little as they could. I was one of those for a few years. And then they had some like older staff members that were theoretically experts about stuff. And I don't know, I learned some stuff about mechanical assembly there at least. There was a lot of the machined aluminum stuff, and some of the mechanical engineers there made an impression on me, telling me how to tighten stuff, and you know, it led me to think about like how the forces are distributed on the screws. And they would talk about having these enclosures with lots of screws around and kind of putting in the corners and then kind of tightening it in like a star pattern so that you would keep kind of balancing the you know, the tolerances that you were eating into with every new screw that you would put in. Oh, Kenneth has a useful figure who says that the camera probably draws 150 milliamps. That sounds about right. I think I did at least do one test where I had the gimbal and the camera plugged into the bench supply, and the current for both of those seemed totally manageable. Alright, those are disassembled. Is that as much disassembled as these need to get? I think so. We've got these two pieces and this final piece over here. And so these have 5 wires. These have 6 wires. Let's figure out which wire we can take out of the ones with 6 wires. Because I still want to make some additional room for the coax before I just put a bunch of additional stuff in this hole that's not going to have room. So I want to be sacrificing the one that was originally used for composite video. So according to my all-knowledgeable sticky note, that was the top pin. Let's make sure that we have these orientated correctly. So according to my diagram, that top one should be video, The one that, see it like snaking through, like between that passive, the one labeled C. Anyway, and then that's plus 12 on that track with the solder mask gap, and then that's ground plane, and then we have 2 digital signals, TX and RX, or pitch and yaw, depending on how you're using it. So definitely that top pin. So the way these are keyed, which one is that? I think that's the white wire. You'd think it would be yellow wire because composite video, but these color codes don't really make sense. Just like extra checking this, because if I cut the wrong wire, that would be super annoying. This does look like it's the white wire. Yeah, yellow wire, some data back and forth. Okay. So that white wire and same on here, or? Oh, is it the yellow wire on here? Did they just not pay that much attention to what order they put the wiring harness together in? Yeah. I think I'm gonna have to not go by the colors, but based on like where this actually is on the connector. Because yeah, this is white and this is yellow, and these are otherwise identical. Let's see if these joints actually have the same end stops, because I'm saying they're identical now, but I don't actually know if that's true. So if I hold this such that the 0.1 header is like at a 12 o'clock position, then this goes from 6 o'clock all the way up to 3 o'clock. And then same test with this one, 6 o'clock. It's very slightly different maybe, but that might just be me putting the tape on a little differently. It definitely goes to 6 o'clock. It goes a little bit past that. If these are different, I don't know which one is which. That could be bad. They have slightly different markings on the circuit board, actually. One has no silkscreen, and the other has silkscreen. Okay, well that might be a problem. I might have to go back and look at how I assembled these, or how I disassembled them. Either way, the pin that I want to remove is the same. And these are all going to be the same connector, and that signal on these is all the same at least. So I have those two, and then this last one is different. Okay. This is the one with the white wire. This is definitely a measure twice, cut once situation, because I really don't get other chances with this unless I want to redo the wiring harness. But yeah, this one is cut the white wire. I found myself really wanting to make sure I'm not misunderstanding the mechanics of how these connectors fit together. That would be embarrassing. But yeah, that's the connector mated. The top wire is the one I'm interested in. Let's cut it. There we go. White wire. And then we can cut that on the other side and then just, well, I think to unzipper these wires from each other, maybe I try to just nip at the white wire with my clippers and then pull it apart. Okay. That's one wiring modification. Then this one, I think we want to take out the yellow, but let's just check again. Yeah, one wire. If space wasn't concern, it would be nice to have this extra wire perhaps for like serial of some sort, but I would rather not stuff these bearings full of more stuff than I need to. So making room for the coax seems really prudent. Okay, so that was the 2 wires I needed to take out. The other modification besides just actually putting in the coax, which is something I want to do with a pretty good idea of which order the joints go back together in. The only other modification is making this pass 12 volts through to the last board over the one that would usually do video. So that is a soldering modification that I'll be doing to board number 3. Oh, nice. At least 50% of the chat is East Coast. Yeah, if you're not in chat, you're gonna have to get in there and represent your location. We've got New York, we've got Kitchener, Ontario, Living Rumor, NYC. Yeah. Board number 3. Let's have board number 3. This one. All right, so on the left connector top pin, that's where the video is coming in. That is going to be a no connect because we just cut that wire. Then finding something to point with. Yeah, so this one's going to be no connect. This one is where we want the 12 volts to go, since that'll be easy to get out. Then that's the actual 12 volt input, so literally I think we just want to bridge these 2 traces. We could cut that if we really wanted to make sure that that wouldn't short to anything, but like literally there is not a wire in that position in the harness, so I'm not going to even be too fussed about that. And that second pin, what is that? I think that's another data. Yeah, on the first one that's used as the mode switch input, but I think it's just going to be some generic data input for the other micros. So yeah, this should be pretty easy. I should never say that, but maybe it's nice to have the motivation. I have a habit of assuming things are easier than they're actually going to be, but I think that's part of what gets me to start things. Just do this with the dullest X-Acto knife blade I have handy. Alright, that should be enough. And then a little bit of solder, a little bit of wire, and we should be good. Oh yeah, someone in chat, Garrett, was noticing that this 0 ohm came out of nowhere. Yeah, this is one of the, so far it's the only difference I've noticed between, so the last board has this 0 ohm, the other two don't. So that's interesting. What is the last board doing with that anyway? I don't know. I don't know if I care that much. It's probably related to how the I2C is wired up. I haven't really looked at the communications between the joints, but I assume it's probably a mix of different protocols. The first joint talking to, you know, whatever it's plugged into could be speaking either serial or kind of model aircraft pulse codes. And then I don't know what the joints speak to each other. And then the last one uses a slightly different pin out so that it can just plug the, so like the moving part with the camera has a circuit board but no micro. And so that piece is speaking I2C instead of, you know, whatever these others are using. Yeah, I hope there isn't any like secret. So yeah, so Rotor Penguin says, sure hope there isn't a secret respin going from one board to the other. And yeah, so far the only change I've noticed is that 1 0 ohm, but there could be arbitrary differences in the firmware, so it's probably still pretty important that I keep these separate. I'm just looking for a tiny piece of wire. I think I'm going to use one of these. Tweezers. Oh, they're right here in front of me. That is huge. That's enormous. Let's make that less enormous. Just without the microscope, it's not enormous. Maybe I cut that with the X-Acto knife instead of the side cutters. That did it. Where did it go? I might have made it too tiny. Yeah, that's probably just about right. Let's do that with some more solder and flux. All right. It should be fine. Okay. I think that's all I need. Now for the coax, I think I just want to start assembling this and take the end that I've already terminated and, well, maybe I'll start by taking this terminated end and reinforcing it just a little bit with, maybe solder it slightly better and then put some heat shrink over it, and then use that as my first end to start feeding into the kind of, you know, the non-camera side of the gimbal, the nominally aircraft side. Let's just solder this slightly more. I've had this same song stuck in my head for days. I could play it, but then I'd get the YouTube copyright bot on me. All right. Oh, and Kenneth's asking which song. Well, I'm forgetting the name because I don't really know the band that well, but maybe Spotify knows. Oh yeah, this is it. "Gray Day" by Zoot Woman. Yeah, I've had that stuck in my head for some reason. I don't know why. That is not pretty, but I think it'll be electrically fine, and with some heat shrink, it might be mechanically good enough. Oh wait, did that break already? Oh geez, how did that happen? Just as I'm saying it's electrically fine, I'm noticing that it's completely not fine. It's like what you tell your therapist versus what you tell the police. Okay. I think that's better. I'm not gonna bother with the crimp, probably. The crimp I don't think is gonna help at all. It'll just sit there. Oh, Rotopenguin says, "Good enough strain relief for Apple." That's, yeah. This is a nice one. Yeah, this is something they would totally ship. How ineffective will this crimp be if I put a crimp on there? Let's just... Oh, jeez. This cable is so little. I mean, this might not be totally useless. It'll at least kind of crimp onto the solder joint a little bit. Of course, maybe the solder joint means that this doesn't fit anymore. Oh, yeah. I did not really flow that solder super evenly. Let's not worry about the cover. I think that's, well, yeah, it'd be nice to have that for shielding at least. Let's maybe just use the non-micro soldering tip to get a better solder cover, and then put the crimp on. Because the crimp isn't going to help with strain relief at all, but it will probably help with shielding to some extent. Oh no! Garrett is reminding us that it's DST switchover tonight, so we get to deal with that. That's interesting. I really hate daylight savings time. I mean, like most programmers probably. Oh geez, this is not strain relieved in the slightest. I might have fixed the problem that was preventing that from having the crimp fit around it. Well, we could all just switch to 64-bit millisecond counts or nanosecond counts. Yay. Okay, well, I think I'll crimp that just for like electrical's sake, but I'm gonna expect the heat shrink to do more of the strain relief than anything else. Crimping tool. Oh, it's so little. What kind is this? I think I want this one. I think this one's too big. Yeah, it's the next one. This one. I think this might be in between two of the sizes on this crimper, which is also a problem. Oh, that looks terrible. Oh, that looks really terrible. Damn. I might want to redo this. I really mangled this with the crimper. Yeah. Yeah, I mean, okay. This might suffice, but it also might be shorted. I'm gonna redo this. I am not happy with this. Sorry, little connector. Redo. I'll use this other one that I was soldering on already. Let's just be... I think if I try to spread the shield a little more, then I might actually get a better mechanical joint. Because like electrically, it's probably fine. It's just, I really don't want something that's gonna fall apart when I look at it wrong. And my cutting board. There we go. Witness the power of my perfectionism, able to destroy any project that does not meet my demands. That needs a little more cutting. Yeah, good time to slip shrink tubing on it, I agree. I'm not going to bother with the crimp thing next time since I think those are just not the right size for the die that I have. Ooh, wrist cam. Emergency wrench to the rescue. Sorry about this. I keep having this problem with this camera arm where the ball bearings in this thing jump out of their sockets. Oh man, all 3 ball bearings were in the same track that time. Okay. Yay! Thanks, emergency wrench. You saved the day. That bit of cat hair in there looks like a tiny spider. Okay, I decided I was stripping this way too much too. So this only needs a tiny bit stripped. There we go. Practice. Oh, question from Mark in chat. Did I make the focus pull ring or buy them? I 3D printed this one. There's a design on Thingiverse for a pretty good one. And it's designed as a focus pull ring, but I just use it for zoom, since this lens has, I forget what the term is for it, but basically this ring is like an optical encoder, and so it doesn't have like fixed positions on here for focus. So it's not as useful for focus, but for zoom it's really nice. Yeah, it's a pretty nice little design. It's a really quick little print, and then you zip tie it onto your lens. I think I've learned my lessons here. I think I want the shield to be kind of scrunched up a little more and to fit in there so I can solder it with a bit more structural integrity. And then I just want to use the bigger soldering iron so I can pump a bunch of heat into the shield. It's not the best for the center conductor, but I'll make this work. And over here I have my wad of shielding. I think I do actually want all of those to go inside. Okay, fine. Change this slightly. I want all of those to be inside, which isn't usually how you do these. Usually you want them to be outside, but on account of diameters, I am changing how this works. Okay, that's not perfect over here, but this will be fine. I just need to not crush it with my crimping tool and it'll be good. I mean, not like crush it in an incorrect and unsatisfactory way that looked like it was going to lead to mechanical failure. The solder sure wets all of this brass really nicely. Should be able to get a cleaner joint on the inside now. There's some anchoring. Okay, this is not shorting, but it certainly does make me nervous. I will just test continuity to make sure this isn't shorted, but yeah, this is looking fine so far. Let's flip this over. Oh. Okay. I think that's probably good. I'm just going to turn this over and make sure the center conductor is still fine. Yeah, okay. Make sure this isn't shorted and then put some heat shrink on it and stop fussing with this. Looking good. All right. Heat shrink. So, might even want multiple pieces of heat shrink here to make it a little sturdier than otherwise. A heat shrink repository. I knew I brought it over here. This might be the first step, like put one of these up to this level, and then put something bigger over all that, and then something maybe smaller over just the cable end. I guess I could use green if I have a choice, because SDI video. It's like those kids' toys with the beads that you put down all the little wooden or the wire tracks. So I'll start with that, plus maybe a bigger one over just that end piece. Man, would it be worth putting the shield on? I kind of don't want to. Well, I don't know. I'm nervous about shielding. Like, that little opening is probably not a big deal, but I think the main thing, though, is if I put the metal piece on, then I'm not going to have a good way of mechanically attaching this strain relief, so I think I care more about that than just a little bit of extra shielding. I'm kind of curious if I can put the crimp on over the heat shrink, but I kind of doubt that would fit. But I'm going to grab another crimp just to see if that has any possibility of working. Oh, this is a different kind. These are the ones we were using. Yeah. Oh, that might be the secret. Ha ha ha. That was like a little bit of, that was a burr from that piece of metal. Not the best machining. But yeah, okay. I think that's getting close to what we want. And then another piece of thicker heat shrink over the metal, maybe? It's tempting to solder that, but I think that's probably making good enough contact. Will that fit on there? I think so. Finding the right combination of heat shrink diameters. Oh, Kenneth is suggesting another piece of small heat shrink under the green. I think that's a good idea. I'm going to try putting something both under and over it. Oh, this is too small. I figured I could do that after putting this piece on. Now I need to pull this off. It's tempting to solder that. Maybe I should put a little dab of solder on that just to make sure the shields are connected. This is really not how any of this is meant to be used. I think that's soldering to the brass, but not necessarily to the shield. It might not be a solderable sort of metal. Oh, or maybe it's just temperature. Great, I think that's sticking. Okay. Alright, that's probably unnecessary, but it makes me feel slightly better about this. Let's put some little heat shrink under that before it shrinks too much. Keeping this thing long. I'll trim it after I know exactly how much of the rest of this I need. Yeah, this would have been easier before heating that up. This whole assembly is actually still kind of warm. I think that's as much overlap as I can get out of it right now, but I'll put another piece over this whole thing. Like a piece that big, and I think I also need something to fill in like around here. Maybe like that. This is complicated. Feels better. I think one more piece and then I just heat this thing up and see if it's at all strain relieved. This tiny, tiny cable is going to be going into the little SDI video amplifier on the robot part of this. That is a really nasty edge. Let's clean that up a little. Okay, that's fine. It's not gonna shrink all the way, is it? Oh well. That looks kind of silly, doesn't it? I can at least kind of squish the heat shrink layers together. So, I don't know. That's not amazing, but I think it might be enough for the job at hand. This will also be a little better once the heat shrink cools. It'll stiffen a bit. Okay. So this goes into the top of the gimbal. Top. Where's the top? The top is this piece. So I'm going to start reassembling this. So gimbal number, or joint number 1. Those little pinhead screws to put this in its bracket. Now I'm playing the game of, do you remember the right screw? Or do you remember the other screw? Oh, this screw is also grounding the circuit board to the aluminum. That's nice. A little... There's a little exposed metal on the board right under that screw. Or at least, I don't know, maybe that was their intent, but it doesn't help. I mean, it's not going to work if these screws are all oxide coated. Servo AF is not helping. Or maybe I'm just zoomed in too far. All right. First joint. Oh, that's not terrible. I've seen much worse cable strain relief. All right. So I want that to have at least decent pigtail length to connect it to my video amplifier. So that's probably reasonable. Something like that. And the first thing this actually has to pass through is one of these little rings. So let's do that. Just looking at how much clearance there is around the opening here because I don't want to squish the wire. I think I have to kind of specifically route it around this plug to get enough room, but that's got some clearance. Oh, now the guessing game of which screws went in here. So we need flat screws. I think we want these. I don't know if I'm going to re-silicone the connectors. I don't have, like, I think the closest thing I have is like silicone caulk, which would work, but like this thing is under a lot less vibration than the actual quadcopter gimbal would be, and I think I'm, like, if I am going to goop up the connectors, I can do that later. There's no reason to do that right now. So then this, next thing we need is the motor that goes here. That could be either of these two. I think it was this one. I recognize this silk screen. I also think they're probably, like, I haven't noticed any differences between these two motors yet. Yeah, let's assume it's this one. So this is the first actual motor bearing space that the coax needs to go through. And then this connector plugs in. Blow the cat hair out of the bearing. Little tiny coax. Not even the tiniest coax. Oh, interesting. I'm noticing the little red mark on this connector and wondering if there's a matching red mark on the other motor. I don't see red on either. Okay. I still don't think there's a difference between these two, but add this to the list of things I'm unsure about on this build right now. Alright, that's the first joint plugged back in. Coax running through it. This is going to start getting hard to shift around, so I probably need to be careful to have this be the length that I want it to be before I put this joint together. So I let too much wire accumulate on this side of the joint. Video amplifier can sit pretty much right on top of this, so it's going to need to be like that much distance. Yeah, this is already snaking enough that it doesn't want to pull smoothly, which it should be pretty well locked in place once it's going through all the joints. Okay. That's maybe a little short. Let's not set ourselves up for problems later. Okay. Seems fine. Now, plug this in. And screws into the motor housing on this side. These are going to be long and countersunk. I think we're looking for these. Oh, the machining on this is actually really nice. Like these two pieces of the housing actually click together with quite a nice feel. Oh, Milan is asking if there's room for a service loop in the gimbal. I don't know what that is. A service loop. If you mean like having like another way to communicate with the camera, I don't know. I mean, I probably could stuff more wires through here, but it's definitely one of the limiting factors here is how much stuff can fit in there. Okay, so now I have these two arms. I think these are identical. Oh, these are not identical. The circuit board housings are the same. The arms are a little bit different. Might have to look at some pictures to see which of these goes back in which order. Pictures. Oh man, I'm not getting in trouble with the YouTube copyright bot if I play any of this, but it's tempting. Pictures are easier to get to on the other computer. Oh, I think the loop we're talking about is something that lets water drip instead of going into the gimbal. I think I might be misunderstanding what we're talking about, because this thing's going to be indoors, so we're probably not talking about the gimbal. Kind of just trying to get everyone to pronounce it Gimbal. Is this like GIF striking back? I still say it GIF. I don't know where GIF came from. So this is our video from the right trigger mount to the third channel, which is mode select. So if you hold that briefly, then I want to see this from, oh, is that it? So this first arm, I think, it looks like it's not as deep as the other arm. I mean, the other thing is, like, I can choose to put this together pretty much however I want, within some limitations. Oh, these are also backwards. So actually, these probably will only fit one way. Never mind. It's still not obvious which way that is, but I think this will. So one of these has the screw pointing that way, and the other one has the screw pointing the other direction. So I think this one goes on next. Let's try that assumption. So that would be this, like this angle, and then the end stops would get it from that position to that position. Then I've got the right trigger mapped to the third channel, which mute button on the keyboard is not working for that, is it? Briefly, then it switches. So that top piece, the wires come out on the back side. And then that first arm stays in the back for the most part. Yeah, I think that's right. Yeah, okay. Cool. Geometry. This is weird too, because the way this is machined, the wires kind of have to take a weird angle right under the bracket. So and that ends up going kind of like that. That's right, actually. Let's try the other arm piece. I would have labeled these if I realized they were so different. wiring angle is much better this way. Does the camera still move like it should? No, it's got to be this one. The other one, unless I put the wrong motor on this one too. But I already checked the end stops on the motors are the same, so given that that points this way, the motor has this range, and this has to point this direction, so it has to be this piece. Therefore, oh, nice. Sean has a clue. The mount side arm does not have the Mini 3D logo, and then the camera side arm does have the Mini 3D logo. Great. That confirms what I think I just convinced myself of. Great. Yay, so this is the one that does not have the Mini 3D logo. And so we're putting this one on the mount. Great, thank you. That helps a lot. I think if I put the arm on the other way, then it would make it impossible for the camera to point forward, which would kind of suck, but it would be pretty obvious that something was wrong. Alright, so here, I think these are going to be pretty small screws. Yeah, like these. Make sure I have 3 of them. Well, really, I want to make sure I have 6 of them, because I've got to do this twice. Yeah, these look like M2x6 countersunk. We should have 6 of those, yeah. Okay, great. It's still nice to put the screws in kind of loose and then tighten them as a separate step, you know, to make sure things are lined up. Okay. Man, I wonder if I'm even going to get the sticker back in place. There's a good amount of room in here for the wires, given that this coax is about the same size as the one that we removed. Alright, so now here's the stationary part again, and this is the kind of back arm that's free to swing that much, which seems right. I think, so that would let me look that far. I mean, basically the camera points, the camera's neutral position is kind of opposite of this bracket. So that's like a good front position. Okay, satisfied. So the next step is joint board number 2, which is this one. So the first one had a red mark, and this one has a black Sharpie mark. So we can go ahead and put this wire in. It'll be kind of thrilling to actually power this all up. I'm looking forward to trying this out. Okay, this looks like an M2x6 pan head. And this is what the board is held in with. I guess it would be button head. Usually you only see pan head for Phillips head, and the metric socket ones are button head. The difference is pretty subtle. Alright. I feel like I might want to try putting this sticker on before getting really into the next joint, but I can see arguments either way. Let's try this. Ooh, that's nice. The foam seems to still work. Cool. Now, just to go through another one of these rings. To kind of carefully route the coax around the connector again. This aluminum bracket doesn't give the wiring that much room. Alright, more progress. Need a couple of long button heads for this. It's at least nice to have a pretty good mix of countersunk and non-countersunk holes to give me some more clues about which fasteners go where. Alright. Next joint. And motor goes in here. That would be this one. It's a cute little yellow wire. Oh yeah, this is some good assurance actually. I can tell that I'm reassembling the one that I disassembled because these two pieces of silicone glue match up with each other. Those two little flecks of white on the left side match. I should have left myself more breadcrumbs like that. Anyway, this wire needs to go through that before I attach it too much. I bet we're going to contribute to global thermonuclear warming faster than CO2 warming, says Rotopenguin. There is that. I do find it hard to get motivated about all the really slow environmental causes like, you know, landfills and recycling and stuff like that, when we've got so many just really big problems that are becoming problems even faster. But, you know, everything is layers of triage. Alright, so we've got coax going through there. Ready to snap the motor in. Cool. Then these screws. These are the really long ones that go through the circuit board and then into the motor housing. Yeah, these three. Somewhere I had a tiny Allen wrench. Is this the one? One more joint down. So now we've got another one of those arms. Yeah. The combination of the hints from helpful folks in the chat and the reference photos and the tape marks seem to be doing enough to help me reassemble this right. So this tape mark is telling me which side the arm points to. Yeah, that one's nice. So are these different? These are going to be more little screws. Are these all countersunk? Yeah, these are all the same. There are no smaller countersunk screws than this one. Nowhere. Maybe that screw is too long. I don't want to use too long a screw and go into the motor windings, but all of these screws are about the same length, so I think I'm fine. Do an axis check in just a sec to make sure this is moving the way it's supposed to. I don't know about this screw. I feel like there are no other choices for that screw, but it looks like it should be smaller. Oh, that's good. That screw is the length it's supposed to be, as far as I can tell. Okay, so this is Camera Town. Yeah, that has way more freedom than it really needs. I think this is good so far. So we have another sticker opportunity and the last axis board. Let's keep this clean on the back. Oh, this also has a matching glue pattern on that connector. Oh, I might have to go to the kitchen and get a beer. I think that would be really awesome right now. I'm gonna sound like such an alcoholic on these streams. Okay. routing this around some more. I don't know if I should route that right next to the switching power supply. Try to use the other side on the other joints. I mean, it is shielded. Shields are only so good, but it should be fine. Okay. Trying to make sure that I don't crunch the coax in any of these aluminum pieces, because that would be sad. I'm definitely getting the hang of the, I mean, well, aside from the thing where all the axes kind of look the same, at least I'm getting the hang of how they design this fastener-wise. It makes sense that the axes would be largely the same, but I suspect that they have to be careful about the particular differences when they're designing and assembling this stuff. Okay, one more sticker here. I'm not doing quite as good of a job keeping the stickers flat as they did at the factory, but I'm also not using like a ribbon cable. It's a couple of separate wires. It's a little different. All right. It's good so far. All right, going through the last motor. Let's take this apart so that we can assemble it in the right order. Again, with the misplacing the wrench. There it is. All right, so I might not even have to disassemble this from the camera, but I should just be able to take the bracket off of, take my bracket off of their bracket, basically. I'd also trim this cable down since, I mean, I don't really want to totally remove the 5-bolt since that might be helpful, but there's at least one wire on here that's just completely useless because it's just connected to a resistor on the other end for USB compatibility. All right, getting close. Take this little cap off. Oh man, maybe I will take a momentary break to realign the cat camera and grab a beer. I'll be right back. Such a little fuzzy potato. You're so good. Of course you get up. Do you want a beer too, Tuco? Ah, yum. Delicious. I really like hops. I'm a fan of hoppy beers. exciting. Never rebuilt a gimbal like this before. So first, let's pass this wire through the motor. It's also still a little mind-blowing that all these wires are going through the motors and the encoder magnets. Like, every piece of this was designed to leave the center axis free, which is pretty neat. Had to unplug the connector on the other end to make a little bit of room for this wire to come through. So now, plug this last cable in. Okay. That clicks into place. Yes, great. And then big old countersunk screws on this side. Okay. I kind of almost want a torque wrench for doing this kind of stuff. Alright, so the coax doesn't have a lot of room, but it can kind of hang out under this connector. Yeah, that is nice and tight. Coax comes through there, and then it can just hang out near that connector as it goes out to the camera. So let's do a quick continuity test to see if our 12 volts is kind of sane. Kind of want the breakout board for the top of the gimbal. This is actually maybe something I could go ahead and install. This is how the gimbal usually mounts to the quadcopter. So that comes up through here. I want the coax to come up through there too. You might have seen this on a previous stream, but this thing that looks like a USB connector is not actually USB. They're using that connector, but it's actually RS-232 serial. It's a little bit janky. Alright, where are these screws? Oh, I think those are these pan heads. Cool. I guess I must like pans more than buttons, which is weird, because I actually am a pretty big fan of buttons. I remember, I think my mom threatened me with like a bag of switches or something as a kid, and she meant like, you know, the kind of sticks that you used to beat kids with, but I interpreted as, you know, electrical switches, and I was thrilled. I think she was just annoyed. Okay, so that's on top. Did I got the coax like stuck between, oh, you can't even see it. I got it stuck between there and there, which it's not like crushed, but then it gets a little bit narrower, so I can't get it into that opening, which is actually where I want it. Let's reroute this very slightly. I don't really want to know what to do for strain relief other than to go ahead and mount the video amplifier and run this cable into that so I can, you know, not fuss with it any more than necessary. Alright. Well, that's better. It's not great, but it's better. Okay, so then that's pretty much our top side. We got SMA and then the original connectors. This has a little wiring harness breakout that gives us power and then basically servo inputs for controlling the position. It seems to also double as a serial port that we might be able to have some fun with. Okay, so now this piece, I was going to do some continuity for 12 volts. First of all, I think this one's ground. Not. Yeah, that was actually 12 or 5 volts. Maybe that was 5. Okay, I guess that is ground. I just tried testing it against two things that weren't actually grounded, namely the rings over here and the shield and the coax, neither of which are actually connected yet. But if I test it against these labeled ground pads, that's fine. So that's ground. This should be 5 volts, which I could test against something in here. Yeah, so that's 5 volts, which we don't actually need. I'm gonna cut that a little short just to remind myself which ones I care about. And then strip these next two. The middle one also I shouldn't care about. So I don't think I'll bother stripping it actually, but I'll strip the last one because that's the one we were expecting to see 12 volts on. That's the one that originally was composite video that we've repurposed for 12 volts. That is not connected to ground except via capacitors. Oh, maybe I'm just misremembering which one of these is which. That's fine too. Let's just strip all of them. This next one, is that one 12? This is also easier with the other breakout cable still. Hey, cat. Okay. I mean, it would be annoying if something with the 12-volt wiring was wrong, but at least all of that is in the last joint, so there isn't much I have to take apart. Okay, ground there. And the next ground. I'll just try all of these, because I don't actually remember. Is it that one? Seems like that one. Okay. And then 12 volts. Oh, I'm not going to get continuity on the cable because there's a reverse protection diode. But if I go from here to the diode, I should get continuity, and then from the diode, I should get the internal 12-volt rail. Okay, left side of that diode then is the cathode, and that's the internal 12-volt rail. So that, this protection diode is like the only active component outside of the actual joint circuit boards, which is funny. I think a lot of this they reuse for their handheld gimbals, but this circuit board is going to be only for the quadcopters. So maybe they don't bother with the reverse protection when they are building the whole thing. Okay. Second from the bottom is the video from what I'm seeing. That looks right. And then ground. Oh, that's convenient. So the two bottom pins, I think, are what I need. So the one that I already discarded actually and cut a little short is actually one of the ones I want. So good thing I didn't cut it too short. So with that one stripped, let's just check that again and then take the wires out that we don't want. So this one's 12 volts, should be at least. Yeah, okay. And ground. Alright. Okay. So now I know which wires I need, which ones I don't. These two wires are not useful. This is going to be the 5-volt supply, which I don't care about on the camera, and a resistor. So those are both useless. I'm just going to cut those so that we don't have as much wire to deal with. And then what we actually care about are these three. 12 volts, ground, coax. So let's put this back on. Okay. Now, camera housing. So, getting the wires ready to go through here. Just checking the range of motion on the joints again. It's looking good. And this stuff goes through at this orientation. Okay, now that's the orientation. Do you want to make sure this can clear the back joint? Oh, that's not great. We might have a clearance problem. This might be mounted too far back for this camera to get much up and down swivel. It's easy to fix. I think it just involves printing this bracket a little bit differently. Okay. Yeah, maybe that's the first actual problem we're running into here. So I think I do actually need to change this design for this bracket to be workable. So the first time I'm actually test fitting all of this. This isn't quite seated like it would be, but it's close. Let's actually get that seated further in so that we know how bad the problem is. Need to get these screws out of the holes because they're in the way. Come on out, little guy. I mean, it's getting almost time where I can cut this coax to length. I've still got a lot of this just hanging out. These little screws are a bit of a tight fit in the hole. I'm trying to get them out. I think that one's just getting stuck on some 3D print debris. push it out while I unthread it, and it's mostly just drilling a hole in my fingernail. Just like launched a screw at my hand. That's one. Annoying. Let's get this coax all the way out of there. And then gently tap this out with a tapping device. Maybe not that. I need a coercion device for this screw. I'll do this on the floor so I don't shake everything on the desk. That was easy. Thank you, hammer. I'll push it most of the way out. I didn't want to send it flying. There we go. Now let's see how bad the problem is. I need to run this back through the coax. Or run this back through the bracket. WDR, wide dynamic range casting. All right, wire is routed. Okay, that's pretty much fully seated on the bracket, and it's not good. So maybe I need to model some of this in CAD, like some of the area that I have free here. In any case, I think making this bracket shorter so that these screws are a little further that way, just making the whole thing less wide, will solve my problem. Yeah, somebody in the chat says, Avante Robot says, coercion device equals alcohol. Maybe I do need some more alcohol. Maybe that would make this fit better. I mean, I could theoretically go ahead and assemble this and see if it works, but my range of motion would be really limited. So like I could kind of hold the camera level, but it probably wouldn't even go to its kind of default position where it's like angled down 30 degrees or so. So I think I might need to go back into CAD and take a look at that. I'm like starting to run out of steam for this stream, but let's go ahead and take a look at CAD anyway. Do a little bit of work there. I don't want to end up messing up the rest of my coax here, so actually I might go ahead and cut this since I think I know about the length it needs to be now. Let's be sure to leave plenty here to deal with the circuit board. That should be plenty. Let's cut it right about at this kink. I'll probably have a little extra piece that I can use for something else. Put this back in a bag. Where did these screws come from? Oh, these are the ones that I added. I guess they can go here. When you put something together and you have extra screws left over, but it isn't because you forgot to put the screws in. I thought I had a little bag I was keeping this cable in. I might have already chucked it. I've got a habit of removing bags as soon as possible because Tuco likes to chew on them. But I can replace the bag with a new bag. Hey Tuco, where are you? Oh, I don't know where the cat's hanging out. Alright, a little bag of spare coax. Oh, Mikey in chat is suggesting an L-shaped bracket, more across the top of the swivel. And I'm trying to figure out what that means. So here we have the whole thing, basically. There's a little swivel. L-shaped. Yeah, maybe. I mean, I think it's probably going to basically have the same shape, but be less wide, but let's take a look at that. Just trying to clean off my desk slightly so that this isn't such a disaster while I'm in CAD. Oh, there you are, Tuco. How are you? Oh, you're such a kitty. Aww. Tuke. What's up, cat? Are you asking for food again? Some of this? Yawn. Might as well turn on the recorder if I'm going to be working on the computer. Record some stuff. All right. Hello, mouse. Oh, that is not the right computer. Where is the remote? Okay. Rhino was fun, but let's go back to Fusion. Oh man, I don't know if I have energy to do another revision of this on the current stream. But let's take a brief look and make a plan. Basically this whole thing, I was originally making this, kind of positioning this the way where I did for center of gravity reasons, but now it looks like we have some other constraints. My intuition is really just to, the most minimal change really would just be to extend this cutout back a little further so this bracket can kind of hang out further into the camera body. One thing I'd been trying to do is to avoid covering up the screws on this bracket, but as long as these screws are accessible, then I don't need to access those screws. So then, these parts of the bracket are not doing any good structurally unless I choose to glue this to the camera, which I probably don't need to. Now I'm trying to parse what Mikey is suggesting in chat. Also, Ryan says, I think there's a balance issue that limits the design too. Yeah, for sure with this camera, since it's pretty front heavy. And then Mikey is suggesting cam over the top of the rotation axis, bracket going back from the bottom of the cam, then down to the mounting point on the gimbal. Let's see if I can parse that. So, cam over the top of the rotation axis. So like, so this is how it's usually mounted. And I guess you're suggesting something where like the camera is more like on top of the rotation axis like that. I don't know. This gimbal is designed to mount in a few different ways. Like you can use it with the camera pointed forward basically, or with this sitting like on top of the quadcopter and pointed forward this way. In this orientation, I might have more room for the camera to stick forward or further back, but probably not much. Yeah, Mikey says they need a sketch window. That would probably help. Maybe is there like some kind of communal notepad we can all hang out in? That would be fun. Yeah, I think I need to wrap up this stream and take a break from this, but I think the next step is probably just to adjust this bracket so that the actually, can we look at this in section view to see how much space we actually have to work with? So this seems pretty straightforward actually. Like this really just involves taking these features over here and moving them that way, or vice versa. And in fact, that would actually make it a little stronger, since this section and this section being closer together is good for strength. So I think that's pretty straightforward actually. I think this is actually a pretty easy change to make. I'm just out of energy to make it. So I think that means it's probably time to wrap up and recoup my energy a bit, but I'll be back with more of this project soon. This has been a fun project, and it feels like we're really close to at least having the gimbal working. The winch bot needs some more work, but the gimbal is looking nice. I'm glad these screws drilled as easily as they did, and the bracket seems to be nice and strong. And as far as I can tell, the coax is working out nicely. We won't know for a while how durable it is, but at least it's small enough and passes the signal nicely. All right. Well, Tuco, how's your food? You just wanted to nibble on that. What's up, Tuco? You want to play? Get the bowl. No matter how frustrating the electronics and mechanical bits get, the Tiger is always pretty great. Well, thanks for tuning in, everyone. Thanks to all my lovely Patreon supporters and fans for continuing to make what I do possible. And thanks for giving all the love to Tuco. I'm sure my cat really enjoys it. I'll see you later, folks. Happy hacking.